back to my YouTube channel. If you're new here, my name is Tien and I'm an aspiring software developer. If you're hearing that noise, that loud noise outside or like near where I'm sitting at, that's not my fault, that's my neighbor's fault. They're doing some construction or moving out or something. And it's been going on like this for like the past 30 minutes. I can't do much about it, but I apologize if you're hearing any disruptions to the video. So without further ado, this video is on Python. And it's a Python video on the Boolean value tables, Python's relational operators, its type bool, and the if syntax. And I gotta say, when you're developing or programming in Python, there's not a lot of math or logic that Python requires you to understand, at least at a base level. So today's video would be relatively easy for you because these maths, I would assume that you have done these type of maths in your secondary school, especially with like the relational operators, where you are comparing which one is larger. So if A is 1 and B is 2, if B is greater than A, then you would return true. But yeah, let's get on to the video. So in Python, when you are talking about Boolean, type bool or the Boolean value tables, it's pretty much the math standard Boolean table. So you have your false and your true. And then you also have your not. So if, for example, if not false, then it's true. Yeah, you know what? I'll type these statements out like last video, and then I'll comment them out, and then I'll post them onto GitHub. So it will be a lot easier and convenient for you. So yeah, I'll just type out the statements first, and then I'll turn them into a comment. So getting back to what I was saying before, so you have your not. So if it's not false, then it's true. But if it's not true, then it's false. So if something is not false, then that thing must be true. And then you have your and. So if both sides are true, then your statement will be true. Otherwise, if both sides are false, then your statement will be false. But in mathematics, it goes a bit deeper than that. So I'll show you what I mean. If you have two falses, then your statement would be false. If you have two trues and true, then your statement will be true. If one of your statement is false and the other one is true, then it will be false. Like vice versa, if one of your statement is false and the other one is true, then it would still be false. Now onto the or. Or only checks one side of the statement. So I'll show you what I mean. If one side is false or the other side is false, then your statement is false. If one side is true or the other side is true, then your statement is true. If one side is false or the other side is true, then your statement is true. And if one side is true or the other side is false, then your statement is true. Or is a little bit different than and. You see here it says true or false. True or false would take a look at true, and then it would be like, oh, that's true. Then it doesn't even have to look at the other side to make the statement true. Unlike in and, both sides of the statement has to be true for it to be true. Otherwise, it's false. Let's dive into the relational operators, and let's just comment this out first. Make this monospace. And let's dive into the relational operators. There are certain syntaxes in Python for you to figure out your relational operators. Most of them are easy. And then the other ones, they can be a bit daunting at first, but it will become easier as you practice them up. So these are the Python relational operators. This means less than. This means greater than. Greater than. And then this one for Python, it means less or equal to, like less than or equal to. This in Python means greater than or equal to. And then here's the tricky part. In Python, if you want to compare if two sides of your statements are equal to each other, it's double equal signs. Single equal sign means you're assigning a value to a variable. So say for example a equals 2, then that means that you're assigning 2 to a. Whereas if a equals 2, let's do this. If a and b equals 2 and 2, so a equals 2 and b equals 2, and if you want to measure them, and you want to return like a truth statement, let's just comment this out for a bit, and let's print this. This would return a true. I'll show you. See? So this means you are comparing if two sides are equal to. This means you are assigning a value to a variable. So let's have this uncomment. Let's clear this and close this. This would be equal to. And then you have your not equal to. So say for example if a and b equals to 2 and 1, so a equals 2 and b equals to 1, then if you want to print a not equal to b, right, and then you comment this out, it would return a true Boolean. Yeah, see? Okay. So that's your relational operators. Why did I start talking about true and false and Boolean values? It's because in Python there is a built-in that allows you to test to see if a variable, a value, or certain objects that you have in Python is a Boolean value or not. So say for example, let's see what that does. So it returns a true because it tests to see if that value, that Boolean value, is a Boolean value or not. So this is where the confusion part comes in. In Python, true or false are objects, and they are both instances of the class bool. When in season 2, when I talk about classes and inheritance and programming with object-oriented programming, I would go into details explaining what instances and objects and classes are in relation to like Python classes, for example. But as for this video, all you gotta understand that true or false are objects, and they're both instances of the class bool. So there's the class bool, and then you have your two objects, true or false, and they're both instances of that class. So when you're speaking about objects, specifically Boolean objects, there are certain logic that you would have to understand first. For example, usually when it comes to 0 and 1, 0 will be false and 1 will be true. In Python, 0 would return a false Boolean value. I'll show you. You remember that print bool 0 right here? Yeah. It will return a false. That's Python's logic, and there are many other different logics that is applicable to Python as well in relations to Boolean values. And so 0 would return a false. Non-zero numbers, so like 1, 2, or 3, would return a true. So non-zero numbers will return a true. So let's test it out. Print bool 1. Let's comment this out. True. Let's do 12. True. So any numbers that are not 0 will return a true, and any number that is 0 will return a false. Let's move on to another logic. When it comes to having strings in Python, any empty strings will return a false, and any non-empty strings will return a true. So I'll show you what I mean. Let's get this handy dandy thing back, and let's have an empty string. By the way, here's a fun fact. That is also considered a string because it's a single quotation mark. This double quotation mark is also a string as well. And this triple quotation mark is also considered a string. But in many cases, triple quotation mark would be used if you have a long paragraph of text. For example, if you're working on indexing like a paragraph of text or multiple paragraph of text, and if that specific block of text is within your Python file and not any other file that you have to import in, then it is recommended that you use a triple quotation mark. But okay, getting back to Boolean. That is considered an empty string. Let's see what that does. It's a false. So any empty string returns a false, and any non-empty string will return a true. So empty strings will return a false, and non-empty strings return a true. They are the principles of Python's logic when it comes to Boolean or type bool. Now let's combine type bool and the relational operators, and we'll be able to see the beauty of Python's logic. What's gonna happen if you have true or 0? 0 would return a false, but it's a true or, so 0 will become a false, right? So true or false, well, here we go. True or false is true. Let's see. Let's clear it again, and let's run it. True. Cool, right? Yeah. I'm just gonna make a series of questions right here for you to figure out on your own. Cool? Cool. I'll speed forward me writing the question bit, and I'll see you guys then. Cool, I'm back. Hi. So those are the questions that I'm gonna be putting onto GitHub for you to solve on your own. And let me know if you have solved it and like my questions. You can either use an online compiler or your own IDE, or you can figure it out by yourself. But I would recommend that you figure it out by yourself, and let's see how you did. Now let's move on to the if syntax. In Python, like any other programming languages, they will always have their own if or else if or like else syntax. Python is the same thing, but the syntax between the different languages are a lot different, and that since this is a Python video, I'll be talking about the Python if syntax. But yeah, for Python, you have either the choice between having if, else, or like else if, and I'll show you guys what I mean. So this is your standard if, and you have to replace the word condition to something else, and it depends on what you want, like, or how you want your output to be. And then you have your else if, and you can have as many as else if as you want. That's the keyword else if is elif in Python. And then you also have your else. But in terms of like constructing your else if or like elif in Python, it is recommended that you don't have like 50 elifs in your program. It is recommended that you have to construct it in a way that first, your logic of your program has to be easily understood, and second, there's no congestion of the elif statements. And after you have your if statements, you would have a certain action. So like print something or get something to achieve. I'm just gonna choose a different word than action. Output. Oh wait, I get why. Because if you do this, then it would create a function, which is not what I want to do at the moment. So I'm just gonna do this. You can have as many as actions in here, but again, don't over congest your if statements or condition. And then likewise, you can have your actions here, actions here. The thing is, before you begin your if statements, you must have some type of inputs for you to figure out what you want to produce. So it can either be a user input, or it could be just assigning a variable like a equals 2, and then you could do something with it. But usually it will be an input here, inputs here, and then the catch is, you remember how I said in the beginning, I was like, the logic of your and the flow of your statement has to be precise. So any actions that you stored in your if statement will be acted upon this condition. Any actions that you store within your elif statement will be based on this condition. Likewise for else as well. So if you put your actions outside here, then your program would always be running your action. So now that you have the base of the if syntax in Python, what do you think is gonna happen if I put an if statement in one of these conditions? So if I put an if statement in elif, or if I put an if statement in here, what do you think is gonna happen? So say for example, if condition here, and then I have my actions here. And then I can have another else here, and then have my actions here. What do you think is going to change the entire if syntax? Well, let me walk it through for you. This is called nesting. So you're essentially nesting like another if condition in your elif if your condition of your elif here is enacted. I'll show you what I mean. So a, b equals to 2 and 1. If b is greater than a, then print, I don't know, true. Elif a is greater than b, and if a equals to 2 and b equals to 1, print true, else print false. And then you have your final else, which is print false. And then you could do something like print hi. Hi is always being printed right here. Let's just do b greater than a. No. So it's less confusing. And then you have false. And then you also have false here. In that logic, you first start with some type of input. So if a is 2 and b is 1, if b is greater than a, print b is greater than a. Else if a is greater than b, which is true, and only if a equals to 2 and b equals to 1, then you would print a is greater than b. Else you would print false. And then at the end, when say for example, if a equals to b, then you would print false. Hi is always being printed because hi this value out here is being put outside all of these if, and else statements. Now let's see if I change that to 1. And let's just change this to a num or something. What do you think is going to be printed? False, because 1 equals 1, A equals B. Else right here. And now let's apply what we have just learned into an actual realistic program. So have you ever made a program that checks for if your current year or whatever year that you input in is a leap year or not? Well, a leap year is divisible by 4, and when dividing that year by 100 is not 0, and if that year is divisible by 400. So how do you put that all into a Python if syntax? Well, we first need to have an input, so an int, and then get the user input, and then have it to be year. And then you would say something like if year mod 4. By the way, this division, when you use this division, you are essentially asking the output to be the remainder of the division. So say, for example, if 2 divided by 1, and then you use this, here I'll show you what I mean. Print computer, print 2 divided by 1. 0. Because 2 is fully divisible by 1. But if you do something like 3 divided by 2, 1. This division, by the way, is called a mod, or like a modulus division. Let's bring this back, and let's bring this back. Okay, so if year is divisible by 4, and year is not divisible by 100, and let's put them into this, or year is divisible by 400, print year is leap year. Else print year is not leap year. We shall see. 2021. Execute. Yeah, 2021. It's a common year. Let's just say that year is a common year, and let's run it again. Oh God. And closing your strings are super important in Python. They don't like that. Year is a common year. And that brings to the conclusion of this video. I hope that you like how I have approached the video by walking you through the Boolean value tables, relational operators, type bool, and have a series of different questions for you to try on your own, Python if syntax, and have 2 different examples. And also that I hope you guys learn a thing or 2 throughout this video, and I'll see you guys next time. Until then, stay safe, and yeah, bye.